Okay, let's talk about functions this time. So a mapping is a function if every input, our domain, has a distinct output, our range. So we're talking about domain are our inputs, what we put in to our function, and our outputs have a distinct output for our range. So what we're saying is that in our domain, so this one here, our domain, we've got 2, 3, 7, 10. They're just our x values that we're starting with. If we add 2 to them, we get to our range, 4, 5, 9, 12. So just adding 2. Now, whatever's in our domain, it has to go to one value in our range. And that means it's distinct. It means it's the only one it goes to. That has to be true for it to be a function. Now, in this case here, we've got a one-to-one function because for every number in our domain, we're just adding 2, and it's given us a value in our range f of x. It's the equation y equals x plus 2, and you can draw a straight line for it. But for every value in a, it's going to one value in b. There are no doubling up or anything like that, which is why it's one-to-one. Let's look at a slightly different one. This time we have got a function this time where we're starting with our set A, our domain of -2, 2, 3, and 5. And that's our domain. And what we're doing this time is we're squaring them. So we're going to square each number. So if we square -2, we go to 4. If we square 2, we go to 4. Now, I just want to focus on this top bit here. Now, for each number in our domain, we've got -2 and 2, and they're both going to a number 4. Now, is that allowed? Well, let's go back to our definition. Now, it says here that a map is a function if every input has a distinct output. So as long as whatever's in our domain goes to one value in our range, then it's a function. So let's go back. So, well, -2 goes to one value. It only goes to 4 when we square it. And 2 can be squared to go to 4 as well. So that's okay. As long as what's in our domain only goes to one value in our range, it's a function. And it's a special type of function, this one. We call it a many-to-one function, because we have, in that situation there, many values going to the same distinct output. So many-to-one is a function because it has a distinct output. That's for y equals x squared. Let's look at one which isn't a function this time. And we can see here that we've got 9, and 9 is going to both 3 and -3. Now, in this case here, this would be a one-to-many, but because the output isn't distinct, because we've got two choices, we've got this one here and this one here for 9, it doesn't have a distinct output, so this is not a function. Not a function. This is actually the equation y squared equals x, and this is not a function because the outputs aren't distinct. And you can see here that this is what the function looks like for y squared equals x. And there's a special trick that you can use to test whether something is a function. And it's called the vertical line trick. So if I draw a vertical line here, if there's one intersection, it's a function. If there's more than one, then it's become not a function. So in this example here, you can see that it's not a function because it's got 2 intersects, so it's not distinct. So it's gone to 3 and -3 if that value here was 9. If I bring up some different ones, so here's a straight line that's linear. Wherever I draw a straight line on that, there's one intersection, so that is a function because it's only got one intersection. That's a one-to-one function. And here we've got some kind of quadratic. It looks like y equals x squared. And again, here we're going to have a many-to-one because we can draw our vertical lines. There's only one intersection wherever you draw that vertical line. So therefore, we've got our many-to-one function there.